Maybe grab the lights, yeah, or lights on, lights off. I don't know. What do you guys think?
Off. Yeah.
Sure.
I don't know. Fall asleep.
That's what I'm going to be doing up here. So I have like 7 cups of coffee. I should probably get more. Good. All right. So welcome to the Electron talk. So kind of the goal of this talk was basically just to introduce this technology. I'm not going to claim I'm an expert at Electron. I've been playing with it for a couple months now. The newest release actually just came out in middle of May. So when it went from kind of pre-development Electron to the full 1.0 version was May 11th, I believe. So as I said, what the goal is basically to introduce you all to Electron, show kind of its kind of how easy it is to get up and running, point out who uses Electron, why use it, and then play around and build out an application with it. So let's first start off with just how big is Electron? Like, if you haven't heard about Electron, it's a significantly used technology these days. So a lot of people are using Atom or Visual Studio Code as their development environment. Both of these are built with Electron. And actually, Electron was built as kind of a process that allowed Atom to be built, and which is kind of the relationship between Atom and Electron. So basically, GitHub said, hey, we want to build a new technology. We want to build an internet or an IDE. So they said, OK, so what do we need to do that? And they're like, OK, well, maybe we can strip out the Chrome browser and build this thing. So they started building out Atom. And they're like, this is pretty cool. This could be useful for other people, and basically made it public and open source. And so because atoms can spin off electrons, that's kind of the relationship. All right. So Slack also uses Electron. So if you've been using Slack and using the desktop application version of Slack, that's an Electron application. Visual Studio Code, some other things you may have heard of, maybe not heard of, like WordPress, perhaps. So anyways, it's becoming more and more heavily used, and it's pretty cool. So, so what is it? It's pretty simple. All it is a JavaScript shell for developing desktop applications. So it uses Node. It uses Chromium, which is a stripped-out Chrome browser. It's driven by the V8 engine. And basically, Electron plays a similar role to like what jQuery does. So for those of you who haven't, we use jQuery a lot. But one of the cool things that jQuery does is it actually determines what kind of browser you're using. And so it creates a similar experience regardless of what browser you're using. And that's one of the big aspects of jQuery. But Electron kind of does the same thing for OSs. And so basically it says, hey, if you're using a Windows machine, or if you're using a Linux machine, or if you're using a Mac, it identifies the OS and then determines how it's going to communicate with that OS such that you kind of get a similar experience out of the whole experience. So, cool. All right, so why use Electron? And so my kind of punchline is native is the new web. So why native? So native is super cool. You get this kind of dedicated reproducible experience, versus having to open up a browser and be like, okay, so, I'm always in my Chrome browser, or always in Firefox. If you're developing stuff in native, it kind of has the same feel. It feels like it's built for that device. And as mobile devices have become more and more prevalent, we are ending up with upload and download data limits. You want something that you can carry around and not be connected to the internet and use. And you want these things to be able to be used a lot. So that's why native. So Electron itself and native applications have direct interface with lower operating system processes, which make them faster and smoother and sleeker than, say, a web-based application. So one application that I like is built in Electron. I haven't played with it a whole lot, but it's Wagon. It's basically a replacement for MySQL Workbench, and basically it allows you to set up SQL queries, set up databases, and then do analytics on it. Pretty sick. But that's kind of the example of what kind of native applications can do is, you can communicate with the database. You don't have to go out to your cloud-based server and be like, I'm going to hit that database. You're just going to be talking to it locally. You get a whole bunch of data back quickly, do analytics on it. Pretty fun. So, all right. So there are other solutions out there for native experiences. So obviously you can write stuff in, I'm going to hide this, sorry. In the purely native language. So if you want to write stuff in C++ or Swift or Java for Android, etc. Another big thing that's been coming up are these transpiled languages. So TypeScript is an example of transpiler. And one of the reasons that people are really jumping onto TypeScript is it writes pretty nice JavaScript. So you can write something in TypeScript, transpile it with the TypeScript transpiler, and the resulting JavaScript is often nicer than what you would write on your own. But the other thing is it determines type, right? And so you're saying, hey, this is going to be an integer when you're using TypeScript. And that allows it to be converted into other languages that are strongly typed. And so you don't always have to send TypeScript and create JavaScript with it. You can create other languages with TypeScript as well. So you can write the same code. It can go multiple directions. So Babel is another transpiler. And so what I consider these are kind of semi-native strategies. And then you have semi-native frameworks. So Ionic, React Native, and Unity are kind of all frameworks that kind of allow you to build stuff in one consistent language that gets then recompiled into whatever native language it's supposed to be in. So the cool thing about Electron is if you're a web developer, it's all stuff you know. So it's HTML, CSS, JavaScript. It interacts with NPM package management. You can have live updates. So for those of you who've been playing with Atom, you'll sometimes see like, oh, these packages need to get updated. And that's part of this whole Electron community is basically saying, hey, you can look and make queries out to the web and say, has there been a change? Is the creator of this application, or if you're the creator of the application, pushing up a new update? And then the user can be like, oh, I want to update it or not. So it has pretty fantastic package management in that sense. If you're like the mean stack, it's very similar to the mean stack. It has some other great tools. So when you're developing using Electron, you can use the normal Chrome developer tools. In addition, there's Devtron, which are kind of advanced developer tools for native applications. And there's its own testing environment, Spectron. All right. So over time, in the last year and a half or so, you can see that Electron's use is definitely increasing. And I think that trend's going to continue. I think there are a lot of web developers out there. They're full stack developers like we all are. You can use all these strategies that we already know how to use. And as I said, and you'll see this shortly, just how easy it is to build a native application with Electron. And so because you can kind of get that native feel, it's super fun to play with. So I think this number is probably even at 1.5 now. So when I got this graph was a month ago or so. All right, so the basics. Super difficult. There's kind of two major processes in Electron. There's a renderer, which is basically what drives the logic for your views. And then there's the main process, and that's basically your controller. So that's it. Those are the two processes. So you have this main process that runs the whole program, and the renderers that runs all the view logic. Cool. All right. So basically the renderer process and the main process Electron's already kind of separated those concerns for you. I just have a list of them here. I'm not going to spend time talking about each one of them. Electron has really good documentation. We'll pull that up at the end, just kind of show you what that documentation looks like. It's been built by GitHub, and you can see like GitHub's README files that they build themselves. They're usually pretty nice looking, and that nice feel has kind of propagated into Electron's documentation. So in terms of its documentation, I think it's one of the cleanest documentations I've seen for any language. And as I'll bring that up at the end. So it's super easy it's very accessible, but it also allows you to do a lot of cool stuff. So, all right, so getting started. This is how easy it is to get started. It's basically a 5-step process. Install node, create a project folder, run an npm init, -y if you want to just pre-populate everything, make things quick and easy. Install Electron as a pre-built application, and then should be off to go, pretty much. So, yeah. All right, so what go into those different pieces? Well, let's start off and look at what that JSON file looks like. So here's an example. So basically, the JSON file that you generate has whatever name you want to give it, its version. And it has a main process that will basically run if you just run that folder. So often it's called main.js. You can call it server.js if you want to kind of think of it as web development, because you can just basically take all the web development knowledge that you've taken from the mean stack and apply it directly to Electron. So you call this server.js if you really wanted to. Most of the literature is showing it as main.js. Every once in a while, you'll see it as index.js as well. And then a start script. This isn't absolutely necessary, but if you set up a start script in your JSON package and put in electron dot, basically it says whatever's in that file, run that start script, which is this main.js file. And then all your dependencies. And these dependencies are exactly like an NPM dependency. So Electron, in this case, is one that we have already installed on this particular JSON file. But you could install Mongoose, you could install EJS, Express, pretty much whatever you wanted to. So if you have some favorite package that you're dealing with or that you really like with NPM, you can use it with Electron applications. So, cool. All right, so the main.js file, again, this thing, kind of think of it as a server. First thing you want to do is you want to just create a function that creates a window. So this is kind of that first function. So basically you say, hey, go get Electron. And for those of you who haven't seen JS6 notation very much, basically what this is saying is create a variable called app. And the curly braces, it's kind of the equivalent of this statement here. So var app equals electron.app. So it's basically saying, hey, make a variable that's the same name as the method in the Electron package. So basically create.
Explain why you're defining them as constants rather than lets.
Yeah, so basically for constants versus lets, constants you have to actively set them. And so we're not going to be adjusting those things, so we might as well set them as a constant. A let is a much more flexible JS6 notation, and it has a getter and a setter, whereas a constant doesn't have the setter pre-built. You have to actually actively go and set it. It doesn't mean it's not mutable. It's still a mutable object or an element, but you just have to be a little bit more proactive about trying to change its value.
So you can't like accidentally override it.
Yes, without intentionally overriding. Yeah. All right. So we're creating a global variable here with main window, which we will want to overwrite. So we want to be able to change this one, which is why it's outside of, or it's a let. And basically we're saying, hey, create a new browser window. Tell it how big it is. So you can put basic CSS styling in it. Tell it where to get it, which file to get it from. And then go ahead and open it with the dev tools on it. You can leave this out, obviously, if you wanted to. And then when you close it, do something. And so again, you'll see a little bit of JS6 notation. So this is just a equivalent of an anonymous function. It has some differences with this statements, but dig into JS6 on your own for that rather than me talking about it now. But it's basically just an anonymous function. All right, cool. So just like any server, once you get it going, you have to turn it on. And so that's kind of the next piece of this main application. So you have to create windows, and then you basically turn those windows on. So doesn't this look strangely familiar to Express? So when you turn this window on, and it says it's ready, then you create a window. When you close all your windows, then you can run a function. In this case, it just closes. If it's a Mac, it waits till you actually hard close it. When it's active, you can, again, run a function. So you have all these different options, and there's more than just the three that I've mentioned here. But basically, you can say, dictate processes that occur when different things happen with your app.
So create window is a supply callback.
No, create windows from my previous. So create windows is this function that I created here. So I'm just firing that as the callback.
Did you export that somewhere?
Nope, this would be in the same file. So these are both part of main.js. So main.js and main continued. Cool. All right. So again, that's kind of the basic start or setup is you have these two processes, main and renderer. And so let's just look at the renderer side of things. All right. So the renderer is something that's going to get required in our HTML. So basically, in that index HTML, for example, we're going to say, hey, go and require renderer.js. So this notation that you're seeing here is server-side specific notation for requiring and bringing in scripts and importing scripts. Because Electron applications are still server-side in the sense that we think about them for web development, you can use all of the kind of the typical node import export strategies, and this is one of them. So we're basically saying, hey, rather than writing script source equals render.js, which actually works fine, we can actually just say, go and require this JS file.
But the file has to be placed somewhere specific for that.
Yeah. Generally, at this point, you go to the correct path for it.
So would you still need like something to manage front-end dependencies or whatever? Or do you even have a front-end at this point, or are you just doing NPM packages requiring those packages?
That's what, yeah, exactly.
So this isn't Bower or any of that kind of
No, but we can use Bower as well. So you can start hooking up. I mean, you can just treat this like you would any normal HTML page. You can say, hey, let's require jQuery. Let's require.
Sure. So yeah,
Yep.
that's what I'm saying. So with that stuff, like you can't just use it with an NPM install. You also have to provide the front-end dependencies.
Yep.
Right. In this situation, you're just sticking with the NPM install. It's nothing more.
Yep, exactly. Yep. Cool. And so in our render.js file, again, what we're saying is, hey, let's create some logic for that view. In this case, all I did was, go and get Electron. Again, set up a remote, which basically says I have access to a bunch of the other Electron pieces. One of those pieces is menu. Another one is IPC renderer. And we'll talk about, well, we'll show what menu does. Well, we'll show what both of them does. And we'll talk about IPC renderer a bit more in the upcoming tab. All right, so all I've done here is basically said, okay, so we want this to feel like a native application. Well, if we want a native application, we want to be able to adjust what's going on up in this toolbar. So we can, and with many of these native applications, we can adjust not only what's going up in our file kind of toolbar up here, we can add icons to, what is that piece of the OS called? But you can add icons up here. So you can make annoying Dropbox icons that you can't get rid of because the Dropbox is annoying. So you have complete access to the operating system, so you can do all these cool things, which is really fantastic. All right. So as I said, this is just a quick example. Basically, we're just creating a new menu, and when we click on a piece of that menu, we're using that IPC renderer to send something back to our main process, and we'll show that in just a second. And then we run that and basically say, let's change our menu objects. Cool. All right. So the way data gets passed around in Electron is why I've been talking about this IPC renderer. So the inter-process communication so much already. And basically what's going on here, you can kind of think of the inter-process communication like sockets. Basically, you send something with a key and data. That data could be a string. It could also be an anonymous function. And then you basically have a listener on the other side that says, hey, when I hear that key, then do something. It's the thing that's slightly different than sockets is it's a two-piece receiver. So in sockets, you just receive the data directly as the parameter gets passed in. With IPC, you pass in the event as the first piece, and then the data as the second piece. So again, this is just an anonymous function. So it says, hey, we're taking two parameters, the event that generated this thing, as well as the data we passed over, in which this case would be data. And then this is the anonymous function, so the arrow function. And basically we're saying, hey, let's create a new window when we hear that, and we're going to load an intro.html page. So again, that intro.html page, you just treat like it's a normal web process. Cool. All right, so almost done with this stuff. So because Electron is basically just Node, it works great with NPM. You can basically just go and get and require NPM packages and use them. So here's an example. So just like that kind of wagon example that I alluded to, in that case, they're connecting with a SQL database and then saying, oh, let's go to the SQL database, get data, start running analytics on it. You can do the same thing for Mongoose. And this is a project that I'm slowly working on, which is basically going and saying, hey, why don't we make a desktop application that allows us to kind of control our Mongo databases using Mongoose through Electron.
So that then required the installation of the MongoDB on the client side before they can actually use the application.
Yep. Yeah, and you can, because you have full access to the system, you can spin up that MongoDB for them if you wanted to. So you can run mongodb off their command line or the user's command line. So cool. And obviously, one thing that I didn't find intuitive was how you set up and use things like Angular or jQuery. And what it turns out is you actually have to set the variables yourself. So you basically have to say, hey, unlike with a normal website where you basically say, oh, just go get jQuery and it knows what $sign is, you have to say, in this window, $sign is jQuery to use it. So
then at any point in time, you use the $sign.
yeah. So once you've described it for that window, then you can use it. But you have to do that. You actively have to describe it. Cool. So just to kind of recap, Electron's super cool, super easy to set up. And I wanted to bring up the documentation just so you guys can see it. And then we'll finish up by just kind of building something out with Electron, just to kind of see how fast that build process is. Cool. So, whoa, that's really small. All right. But as I said, I find the documentation quite readable. So there's guides as to how to do things. If you look at a different process, like I think GitHub just pretty much mastered how to show and display files. I think their use of white space is really clean. I just find it very readable. I don't know if you guys do, but I really like their documentation, if it's not obvious already. So, and what's great about that is because it's so easy to kind of get going with Electron, then if you want to do something cooler with it, going and finding that documentation is, as I said, quite easy, so you can try different things easily. So, and it definitely has a growing community, so it's super good in that sense as well. Yep. Yeah, exactly. All right, so that being said, let's go ahead and make ourselves an Electron app. Sound good? All right, let's do it. So cruise on over to my terminal. All right, clear this. All right, so just get going with our Electron app. I've already started a little bit. So just open up Atom. So we're basically making an Electron app with an Electron app. So yes. All right. So when I say I started a little bit, here's what I started. I created a index.html, which basically just has and requires the renderer. I have a couple of input fields in here. I have an empty main.js.
About the renderer, I'm still unclear.
Yeah.
How did did you install the renderer with like an
So
manager?
Yep. So
How to get where is it?
yeah. So this renderer process is just a file that we've created. So it's just an empty JavaScript file. Yeah. All right. So right now it's just saying, hey, go and require this blank file. It's not doing anything just yet. So we haven't done some of the other things. We haven't done the initial setups like npm init. We haven't created our JSON package. If we're using Bower components, we haven't installed any Bower components. So let's go ahead and do that part of the things. But I just wanted to show you kind of where I'm starting from so it's not too nebulous. So, and that was a great question. So as I said, we started with these 3 files. They aren't doing anything yet. Think of them just like the regular JavaScript files that would not be doing anything. All right. So let's start off with npm init. That's all fine. Cool. All right, and then let's npm install Electron pre-built and save that. Electron is a fairly large package, so it does take a little bit of time to install. Cool. Yeah, and if you're building a lot of Electron applications, you can globally install it so that you have access to it. All right. For this particular application, we're not going to build anything else. We're just going to have those 2 things. So we're going to go in and first we're going to edit our JSON file. Excuse me. All right, so now I have this package.json file. All we need to do is add a start script onto it. And we're just going to say, hey, when we start, run Electron bot.
Is it required?
It's not required. We can just, if you wanted to, you could just run Electron dot directly from your command line, or Electron main.js would both work.
You can technically do this inside like any NPM application. You can throw a start script in there and set the start script like node monster.js.
Yep.
You can just do npm start.
Exactly.
That's the entire purpose.
Yep. Cool. All right. So let's go into our main.js file. All right. So I have some pre-built Electron code. So I'm just going to use it because that's really boring to watch me type. So this is just the same exact stuff that we talked about before. So basically we're saying, hey, go and get Electron, create an app, create a browser window variable, create a main window variable, have that function create window that basically when you run it, it creates a main window. But at this point, we haven't turned our application on. So let's do that next. This is going to be the activation stuff. So basically it says, hey, we've got that variable app. When we turn that thing on, let's create this window. When we close the windows, we could do something like console log if we want to. I guess it should be goodbye world, right? Since we're closing a window. I know. And I hadn't converted all my snippets to anonymous functions, but we can change them to anonymous functions or to arrow functions if we want to. So just to kind of see what the conversion is, that's all it is. All right. Makes the code a little bit cleaner. And it controls this, as I said, in a different way than a typical anonymous function, which is pretty nice for certain things. Yeah. Cool. All right. So all we're saying with this code is, all right, so when we run this create window method, create a new browser window that has that height and width. Into that browser window, load our index.html file, open up the console log, so the developer tools, and then when you close it, you can run another function, and that's it. Cool. All right, so at this point, we should be able to actually run it. So we have an index.html here. It's got some stuff in it. It requires renderer.js, which is an empty JS file, and should be good to go. So let's give it a shot. If I can figure out where my terminal actually is. All right, so npm start. And it automatically does that, and there we go. So let me just full screen that. So we have these nice, make this a little larger. I don't know if I can, so it doesn't seem that plus works, but here's our input that I had in our index.html. Here's our typical looking Chrome developer tools. But this thing isn't Chrome. This is an Electron application. All right, so this is the toolbar that's controlling this application. So if we do quit, oops. All right, and look at our terminal. Oops, I was thinking it was going to console log, but it obviously didn't. But let's.
You have the console log when you close window?
Yeah, I think I did. So let's just close this window and see it. Yeah, there's the goodbye world. So cool. All right.
Obviously, you can change the taskbar so it doesn't say Electron, right? It would say the name
Yep.
of your application and all that.
Exactly, and we're going to do that right now. All right. So that's starts to be the renderer side of the logic. All right.
Is anything you've written, is it cross-platform at this point?
It is.
It is. So at this point, that would have worked on Windows or Linux. Yeah.
Exactly.
Same result.
Yep. Yep. And it would have changed like the buttons and how those look depending on what platform you're using.
When you do menus, though, is that
Same thing.
independent, or is that also cross?
It's also cross-platform. Yep. Yeah, and so basically what Electron does is it says, if this command is available for that platform, then it will make it equivalent to what that platform expects. So for a Windows machine, these would become square buttons. If you set up a different menu looking thing, it will adjust things as appropriate. So with Apple,
Opens up, like, the-
what's that?
Sorry.
Good.
Oh, it basically just like opens up the main operating system's Explorer shell. Right?
Yep, exactly.
And just throws the application inside there more.
Pretty much. Yeah.
Certain elements like trays,
Yep.
icon trays operate differently. So at some point, though, you're going to have to execute OS-specific stuff based on what you touch anything it is.
Yeah, exactly. And so that's what kind of the role of Electron is it figures out what operating system it is, and then if you say, go to a tray, do the correct operating system behavior as well as Electron knows how to do it. And so Electron initially started off as OS X specific, and that's one of the reasons that took so long for it to go from its initial release in 2014 to its 1.0 version is figuring out how to go to a Linux machine or how to go to a Windows machine or how to run things properly in an OS X. So once they figured out that part out, they're like, okay, so we're good to go. We're going to release this, let people develop native on cross machine. It's basically the idea. And as I said, it's kind of the same idea as what jQuery does. jQuery says, hey, what kind of browser are you using? And then it runs the correct code. So if you're using an older version of Internet Explorer, like jQuery 1.x is basically built to be retroactively throughout all of the Internet Explorer lifecycle, whereas jQuery 2 and above isn't retroactively available or doesn't work with all of the Internet Explorer stuff, but it works with all the mobile stuff. And so if you look at the differences, I mean, that's why both of those two lines are still continuing in jQuery. And so Atom's doing the same thing. Instead of looking at what sort of browser you're using, it's basically, Electron, it's saying, hey, let's look at what OS you're using and then run the appropriate command. So it basically makes all this forking logic. All right, so let's play around with our renderer. And let's see what we've got here. Let's do that one. All right, so again, we're basically saying, okay, Electron, go ahead, get Electron, set up our remote, let us talk to our main, if we click on something, and change our menu. So we created this menu constant, but we actually haven't invoked the menu constant and created that new menu. So at this point, if we run Electron, our toolbar is going to look exactly the same. So we have to actually say and use this menu method that we've generated up here, our menu constant up here. And I can't remember the syntax, so I'm just going to look it up real quick. It's going to be renderer. It's just menu, set application menu.
Do you know if you can set the Electron constant globally rather than having to put it on every page?
The Electron constant globally, like
So that it's just being passed to every page.
you cannot. You have to require it on each of your view renderer pages. Yeah. All right. So all we've done so far is we basically said, hey, when we generate a new Electron application, let's also make this submenu, change the label to Electron, and have that submenu when you click on it, console log click, and it sends something off to our main function, which has the key of hello, and it sends some data over. We haven't made the listener for that yet. So let's go ahead and see what happens when you run our application. Oops. All right, so notice now our toolbar is just Electron. Inside of it, it has one thing that says about Electron. If we click it, it should console log. And if we look at our console, there's that console log. So we can click it again. And it tried to send something back to our main process. But our main process doesn't have anything listening for it. So let's make a listener on our main process. And we have IPC already available. No. Let's make constant IPC main. So now we have IPC main listening. So now we can listen for something. IPC main dot on, and I forgot what I called that method. I think it's intro. Oh, hello. So again, it's just like how sockets behave. And it's going to be a data with two things, so event and data. And so here's our function. And let's just console log data. So we should expect to see, here's some data or something to that effect when we console log this thing. When we click, we should see a click on our client side, and then a whatever the data that we're passing over on our server side in quotes. All right, so let's close this version of Electron. Oops, I'll have to hard quit it. All right, so again, just go up to our drop-down menu. There's our click there, and there's the sum data getting passed over. Cool. And that's basically all it is. I mean, at this point, you can basically use React or Angular or whatever you want to do and drive your development, however, in whatever direction you want to drive it. So you make AJAX calls out. So we could make a quick Pokemon app if you guys want to see that. Just kind of, sure, we can do that real quick. I have the snippets built, so it'll take like half a second. Yeah.
How would you package and distribute something that you've created like that? It's like if I wanted to run your app on my computer, how would that process?
It's pretty easy. I don't know the whole process because I haven't played around with it too much, but the it's a relatively straightforward
What happens if
application.
two people, can you run two Electron applications on your same computer?
Sure.
So the servers would just run as two separate processes.
Yeah, I mean,
two separate mains and two separate processes.
Yeah, exactly. Because when you package it, it basically, depending on what or how you package it, it creates basically a folder structure for itself, right? And so then it accesses all the internal folder structure of itself. And we're running two Electron processes right now, right? I'm running this one, which is the one that we just created, and I'm also running Atom. Cool. All right.
Are there any operating systems that aren't supported?
Yes. I mean, the main three are the only ones that are supported. So
No Android.
Yeah.
That's too bad
Yep.
because that would have been very handy.
Yeah. I'm sure they're working on it, but they haven't gone there yet. Cool. So let's go ahead and make a little Pokemon app, just to see that you can kind of use it in other ways. So basically, all we're doing is making an outside API request on a local system. So it's npm init, or power init, sorry, blah, 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 blah. Sure, it looks good. Power install jQuery, because as much as I like writing curl commands, I really don't. All right, so now we have jQuery. We're gonna basically go and get jQuery, bring it into our renderer, and have some things happen. So let's see what we want to do. Electron, Pokemon. So as I said, I didn't want you guys to watch me type all this stuff out. So if we look at our index.html, we have an input field that has an ID of poke index and a button that has an ID of intro. And so in our renderer.js, all I said is, hey, let's create a jQuery constant or global. Go require jQuery from that Bower component that I just installed. So if we look in our Bower components, basically it's sitting in this distribution right there. And then I said, hey, using jQuery, when we click on that intro button, let's run a function. Let's go to the IPC renderer, send this intro key. We're not doing anything with that IPC renderer at this point, so we aren't listening for anything on main. But we're making an AJAX request and basically saying, hey, let's append to the body of our page whatever sprite that we found from that request. All right. What's that? Cool. All right. So we can choose whatever Pokemon up to 500 that we want. So let's do 101. I have no idea which one that is. Introduction. Oh, come on. Where's your click? I think I did. Oh, couldn't set selected background color from default. Let me see. Front row. Let's see where I tried to do that. Oops. Weird. Not seen it do that before. That looks fine. Let's comment out this IPC renderer just in case that's it. Why would it be calling the background color? Source equals that. Does anybody see it? All right. Let me just look at my index.html real quick. Nothing in there that looks like it's weird. All right. Let's just close this guy again. See if there's any. Okay, nothing happened there, so that looked fine. Let's do introduction. All right, there we go. Maybe it's something with that particular jQuery call, or that particular Pokemon. Anyways, so now we can make a Pokemon API or whatever. So. Where can you get Electron? No. I can give you the code. Or you can write the code in like 10 minutes. Cool. All right, so that was it. So as I said, I'm not an expert in Electron, but I think it's super cool, so I wanted to introduce it to you guys. And if you like the mean stack, I think it's a really fantastic tool to play around with. And then you guys can teach me awesome stuff. So cool. With that, happy to take more questions. I can try to answer them. If there's any questions from you people online that are watching, you can make fun of me or ask questions, either one.
Having the native app, but possibly keeping data in the cloud.
Yep. And
having a way to like onload, grab the data, be able to manipulate the data locally, and then on close, push the data.
yep, and totally, and that would work great.
Yeah.
I mean, we basically just did that effectively, right? This could have been, instead of being an API for Pokemon, it could have been our cloud server that was serving our data. Cool. And it's super fun. I mean, it's super easy to set up, and it's super fun to play with. So if you get a chance, definitely take a look. So. Cool. I think if there's no other questions, thanks for listening, everyone.
Thanks,